Hello and welcome to Aerosoft Australia's avionics package for the Boeing 737. My name's Andrew McLean. I'm the developer and owner of Aerosoft Australia. I'd like to give you an overview of the package now rather than an in-depth look. So let's start with the main screen here. On the left we have the primary flight display. On the right the navigation display. Above that is the mode control panel. Now let's just turn off the mode control panel. And with the right click of the mouse, we bring up the only menu in the system. And here we can turn off the navigation display. And we're just left with the primary flight display. Right click again and select Move Primary Flight Display. If we hold down the control key, this display can be moved anywhere around the screen. And with the Shift key, can be resized. So let's just move the primary flight display to the top left. Right click on the navigation display again and position that at the top next to it. That's a decent size. And we can show you the other screens, which are the ICAS. These are the engine screens. Again, these can be positioned and scaled. Now you notice that these displays overlap, so you can actually just use one computer monitor to position these displays anywhere you wish. The last screen is the ICAS lower screen. Again, positioning, scaling, and moving onto the screen wherever we wish. Those are the four main displays, along with the mode control panel, which can also be moved around the screen. And the last one is the flight management computer. I'll go into detail later on with these in other tutorials, but for now, let's just take a look at this overview. I'll just declutter the screen by turning off the other displays and resetting these displays here. Now the system's been designed to be used with Microsoft Flight Simulator, and the way it works is Microsoft Flight Simulator interfaces to the software using the aeroServer software. The aeroServer software interfaces to the avionics. Now you can run it on one machine, which is what I'm doing now, or across a number of machines on a network. So if you're setting up a home cockpit, this is ideal software for you. Let's get the aircraft flying now. We're going to press the toga button, which is takeoff go round. That button advances the throttles on the aeroplane to a predetermined takeoff thrust. And on the primary flight display, the magenta bars here give you pitch and lateral commands, but for takeoff and go around, we'll just get the pitch command. We also need to arm the auto throttle, and at this point I'll press the toga button. You'll notice that the magenta bar indicates that we need a -10 degrees pitch down, and on the left the airspeed indicator will start to rise. At 60 knots we'll be commanded for a pitch up of 15 degrees, and at 84 knots the throttle will indicate thrust hold. We can then retard the throttle if we need to abort the takeoff. On the left here you'll notice the rotate speed of 135 knots followed by the V2 speed. Now because it's in automatic mode, the plane will take off by itself if you watch down here on the Microsoft Flight Sim display. And at VR the aircraft rotates. Now it's set to climb out at about 167 knots. So I've got a positive rate of climb, gear up. Let the aircraft accelerate. You'll notice that it's hit the 167 knot speed. The aircraft is climbing at 20 degrees pitch up, and the throttle is now set for arm. At this point, the takeoff is over with. We press the command button up the top here. That initiates a speed mode, a level change mode up to 4,000 feet, as well as a heading hold mode. I have a flight plan pre-programmed here, so what I'm going to do now is hit the LNAV button, which basically means the aeroplane, represented by this symbol here, will follow the magenta track line to the first waypoint of Cathay. Let's increase the speed now to 250 knots, and let's get the flaps up. Now that probably should have been done a lot earlier. So you'll notice now that the aeroplane is starting to accelerate. and to its target altitude of 4,000 feet. While the aircraft is accelerating and climbing to that altitude, I'll show you a few other pieces on the software. I happen to have some GoFlight hardware plugged in at the moment, and we'll just minimize Flight Sim. We can see on the navigation display here to the right, we can alter the scale. We're flying up to Brisbane, which is north of Sydney. It's about an hour and a half's flight, and you can see the scale is changing there. I can display various waypoints around the aeroplane. I can display airports. If I change the scale, you see other airports are displayed. And I can display stations, which are NDBs and VORs, represented by the green symbols on the display. Now we're coming up to the Cathay waypoint. I'll bring up the aeroplane again, and we'll just wait and see what happens. Top right hand side of the display tells us we're coming up to Cathay. We'll hit that at time of Zulu 346. Now you notice it's changed to shore. The aeroplane is now starting to turn to follow this magenta line around Cathay. We'll just let the aeroplane finish the turn. Now the way the aeroplane works is that the autopilot is completely reprogrammed. I'm not using Microsoft Flight Simulator's autopilot at all, so we're going to get very, very good tracking of the VOR, the ILSs, as well as the flight plan itself. Now I am using the Microsoft Flight Simulator altitude and vertical speed to control the aeroplane, but for all intents and purposes that's actually seamless to the end user, to the pilot. So you can see now we've just tracked past the Cathay waypoint. If I bring up my flight management computer, the progress screen, we can see we've gone from Cathay at an altitude of 4,000 feet at that time with that fuel to shore, distance to go, ETA. Have a look at the leg screens. These are some of the other waypoints we're going to hit along the flight. So we'll just leave that there for the moment and have a look at another section, and I'll just pause the flight sim. Now I've set the system up for a landing on 16 right with a ILS. Before we do, let's have a quick look at some of the other functions. On the navigation display, we're in map mode. There's also plan mode, back through map to VOR mode, and back to approach mode. In approach mode, the magenta line here is set via the course, which is up here on the MCP. If I park the mouse over the number and use my mouse, I can alter the course. That's using the mouse wheel, or I can click to the left to decrease the numbers, click to the right to increase the numbers. If I hold down shift, we can jump in increments of 10. So 16 right is 155 degrees, so let's set that up for 155. In the flight management computer, the approach reference speed is 128 knots for flaps 40. The aeroplane does have flaps 40 and gear down at the moment. And you'll notice here I've set up the speed bug to be the reference speed plus 5 knots. Now you'll notice that the aeroplane is heading 185. It is actually intercepting the ILS. Let's go inside the aeroplane. You'll notice it's starting to intercept the ILS now. As I mentioned before, I'm not using the autopilot in Flight Sim at all, except for altitude. So these routines here are the software flying the aeroplane simply by using the ailerons. You can see Sydney in the distance, and on the primary flight display, we've almost intercepted the localizer. The aeroplane is now descending to intercept the glide slope, and the magenta flight director bar is coming to the center of the display to show us that we're almost on the ILS. Down the bottom here is the radar altimeter. That's the height above ground level. That's AGL. And very shortly, we'll see the display of a thing called the rising runway. At 1,000 feet, there it is. As we get lower, the runway will rise, giving us an indication visually of how far we are above the ground. Over here, we have a white line at 1,000 feet indicating 1,000 feet above the runway. This yellow bar indicates 500 feet above the runway, and this green bar indicates the decision height. I can alter that, and we're going to say 200 feet in bad weather. That's what we actually need to look at. This yellow bar, this yellow marking down here indicates the elevation of the runway. At the moment it's sitting at 0. Sydney's 21, but I haven't programmed that into the flight management computer yet. Here we go. You can see the aeroplane is being flown by the autopilot that I've programmed. We'll go to an external view. 50 foot above the runway, 30 foot, and touchdown. I'll disconnect the auto throttle. Turn off the autopilot. I'll just pause the sim there for a moment. I'll alter the display. We'll just turn off the primary flight displays, and we'll load up the ICAS display, and I'll resize that for you. We'll also load up the other ICAS display. I'll unpause the sim, and I'll select reverse thrust. Okay, so the aeroplane is now slowing down. Get the speed brakes up as well, the spoilers, and apply the brakes. Now at 80 knots we should retard the throttles back to idle, and shall keep the brakes on. Notice our fuel tank is quite low in the outer wings, high in the centre. Now this wouldn't actually happen in the real aircraft. You need to load up the wings, either wings with the fuel, and use the fuel from the centre tank first for structural reasons. Okay, we'll apply the park brake here, and I'll shut down the engines. Control Shift F1, and you'll notice that the engines spool down. Engine indicator lights over here on the right indicate low oil pressure, and we can see if I increase this display, we have low oil pressure indicators as well. So that is the Aerosoft Avionics, the aeroSystems package. There is a lot more to go through with the flight management computer. A lot more screens. We haven't even talked about planning, legs, progress bars, N1 limits for takeoff, or the menu, which is navigation radios. This does not exist in the real 737, but I've included it here for ease of use. Very quickly, if we want to enter an airport, say Sydney, YSSY, we enter the airport ILS here. We have a choice of runways and frequencies. I know it was 16 right. It gives you the frequency and the course. Simply by pressing the outer line select key, it activates that frequency. Go back to the radio, you can see it's automatically tuned here. Same with the navigation aids. I enter CAA for Calgary. Select Nav Aid. I want the NDB at Calgary. Select the Nav Aid. I tune it to ADF1 or ADF2. Down here on the right, I can select the ADF right. On the left here, I can select the VOR. In this example, let's use Sydney. SY for the Sydney VOR. Select Nav Aid. A list of waypoints or nav aids or entries that come up with the SY name. I want Sydney VOR, not Kirky NDB. Select Sydney and load it into Nav1. Now I'm in approach mode on my display. That's why it says EFIS mode disagree. I select the VOR mode. There's the VOR mode there. When I alter my course, you can see the VOR changing. That's basically the Aerosoft systems. I hope you've enjoyed this demonstration. I will be going through the systems in detail in other tutorials. Please feel free to contact me. The email address is info@aerosoft.com.au should you have any questions. And thanks once again for taking an interest in the Aerosoft software.